In my last video, I showed you how to create a spaceship in Basic, which runs on the Color Maximite tool, which I've got right here. Now, the design that I came up with last time wasn't much to my liking. It didn't look that much as a spaceship, but I improved the design a little bit for this video, and I will show it to you right now. So, you see I have the program which is running in background. You can run it like on the with the F2. My program is ready to run, so if I press F2, it will run, and you can see my spaceship right here. It looks more of a spaceship design, and I pretty much like it, and for the purpose of this video I will keep it as it is. Now let's see, if I press the arrow keys, I also added some kind of movement thing, so you can move it around. Now it's not perfect, I'm not really satisfied with this, but I can move it. The thing is that I can move it, and you also can see a couple of flickers on the screen, which happened because on each draw of the movement, I practically clear the whole screen and then redraw the spaceship, which is very time consuming and inefficient as well. But first of all, let's have a look over the code. First of all, in the code, I added some constants like snout radius, snout skew, and let's say the body with it. And I also used my library, which I created to get the screen width and screen height, just because I also run it into the emulator, and I also want to run it in the PicoCalc to see if it works. But practically, I amended a bit my draw spaceship function. As you can see, practically I'm using a polygon and all these coordinates to draw the body, but first I draw the circle, which is practically the snout that you can see a little bit bent. And once I do this kind of draws, I also draw the left and the right engines with these functions, and they are going to be like in the orange, sort of an orange color, as you could see. And this is my old code, which is commented. And for the movement, I created a bit of logic here. So practically I have the position, which is going to be initialized with the center of the spaceship X and Y. The initial spaceship X and Y, I think they are going to, yeah, they are defined here in the initial setup. So if you can see, you get the X will be the screen center and the Y will be the screen resolution minus snout radius minus 20. It's sort of in the screen, in the center of the screen, but it's not really that efficient. I mean, it's using minus 20, which is a hard-coded value, and it can change in the future. And I'm also using another two variables called the last position y and last position x. Okay, and next I'm going to define this particular block here, which is being called on the key press. Now, to get the current key which is pressed in BASIC, you can use the in key $. This is a variable, a read-only variable, which will tell you which key has been pressed. But this comes in as a string, so that's why I convert it to ASCII. Then in the with the ASCII code, I can then use this switch case to move the thing around to change the position. And as you can see also in my comment that I left here, you have the left is 130, right is 131, the arrow up key is 128, and the down is 129. Super cool. Let's move on to the next blocks. The next thing that I do is to define what function to call when the user presses any key on the keyboard. That's why I use on key, and I supply the function on key press, which will be called on each time that user presses the key. Then we have the main game loop, so to say, which into which I just check if I have the last position different than the current position that is going to be changed by the on key press. And since this last position x and y are defined with -1, so the first call to this function, the first loop into the which program runs, it will automatically enter this if, which will use the clear screen command, and then it will assign the last position x and y to the current position and withdraw the spaceship. Yeah, if anything changes, then it will draw. So there's not going to be any kind of draw if there's no position change, just to keep the things clear and stop flickering the spaceship every frame. Now to get the frames, I'm using the pause function, which receives as an argument the milliseconds that the CPU will pause its execution. Now I aim for 60 FPS, which is for this example very attainable. That's why I used 1000 milliseconds divided by 6. So like you will get around 60 frames per second in this case. So I think it's super cool for now. It runs, but it's not perfect. Let's run it once again and let's see how it behaves. So I have the spaceship. The thing is that if I'm keep pressing the up arrow key. If I press the left key, it kind of stops for a moment. And I have now both of the keys pressed, but you can see that it's going only up or left. If I have, let's say, up and left, it should go into the diagonal like this, but it doesn't go. And it's also very flickering and very slow. So what I'm doing with the clear screen command is totally inefficient, and I don't really like it. So let's dive into this tutorial. Let's improve our draw function so that our spaceship draws smoothly and it's able to move around freely and without flickering, and also into the diagonal if the user presses both of the arrow keys. So let's see how we can do that. Okay, time to exit our program. So if we hit F4, we can edit the program, and I would say let's start with the flickering. Let's try to amend and solve the flickering issue. Now the flickering comes from the fact that I'm redrawing all the screen each frame, and it is very inefficient since I only need to redraw a part of the screen. But in order to make it efficient, we can use the BLIT command. Now the BLIT command, let's say we are in the spaceship, and let's try to use the BLIT command. Draw spaceship 100, 100. Snout color is not defined. It's not a problem. But let's try with a simple circle then. If we say circle 100, 150, it will draw a circle. Now let's move it a little bit to the right side because it's going to, yeah. Now with the BLIT command, we can practically copy a part of the screen. By copying a part of the screen, this is an operation that will save into the memory that particular part of the screen, and then we can draw it somewhere else. Let's use the BLIT command. So if we say BLIT, first we need to define which buffer we use. You can either use hash or without hash here, so I'm going to try to use the BLIT 1, and in this case I'm going to use simply because the circle center is right here, I need to BLIT the square of this part. So I'm going to take the center and I will, which is 300 and 300, and I'm going to subtract the radius, which will be -50, so it will be 250. 250, 250, and the height and the width of it, they will be both 100 because it's the radio multiplied by 100. And to make it work, it will be here, I think it's going to be BLIT read. Okay, didn't throw any error. Let's try the opposite command of BLIT read, which will be BLIT write. BLIT write. In this case, we'll say BLIT write, the first one, and then we can specify the coordinates. Let's move it like 500, 500. Let's see. You can see it's actually drawn. The same thing here is drawn right here, but it misses these coordinates. I mean, when I say BLIT read, I should increase the width and the height. But BLIT read, BLIT one, if I use it with 101, it will throw an error. Because we ain't got the, we have the buffer there, but it's going to be using a different size. Okay, let's clear the screen and let's draw the circle first. And then the BLIT read 250 to 50, and then the BLIT write. We have a perfect circle. And we say also what we can do, because this command, when it writes, it also writes the transparent pixels. So sometimes it's not that efficient. So let's see if we are, how it writes if I like change the position to be a little bit to the right. It seems it's ignoring. Okay, I thought that will overwrite everything, but it seems to be strange because on the emulator it actually draws it all as a rectangle, so it overrides everything. What if I use this B100? Okay, yeah, seems fine. That's why I think programming these devices can be a little bit tricky because they behave very differently depending on the device. I did a couple of bit of research in the emulator before, so it really needed that this parameter with the binary 100 to specify that it's going to copy only the non-transparent pixels. But it seems this guy copies the non-transparent pixels only, so we can be fine. But I would recommend to specify this parameter just to make it aware that your intentions are to copy the non-transparent pixels only. Okay, now moving on to our code, how we can use this. So first of all, we are before the first the game loop, so to say, we are going to we need two BLIT commands, one for the actual the background. So this background will practically replace the last position. So that's why I'm going to use the BLIT command, BLIT #1, and which is the position that we are now. We are in the position X. So I'm going to use position X. But the thing is that the spaceship, when you specify the position X, it will be actually the center of the spaceship. And we, in the BLIT command, we need to draw a rectangle. So let's first see if we can draw this rectangle to show you what I mean. Let's draw it in the spaceship itself. Let's draw it right here. Box. And it will be X minus body width size. We will the y coordinate will be y minus snout radius. Then we need to specify the height. The height should be something like body, not the height, sorry, this will be the width, body width size multiplied by 2, something like that. And then we have the height, which will be the snout radius multiplied by 2, plus, because we shouldn't forget of the engines, which are down below, engine height. And let's specify the color, so it will be RGB white. RGB white. I think it should do the trick. Let's run the thing and let's see. Body width size is not declared. It's not size, I think it's side. Yeah, side. Not a problem. Yeah. This editor is not very useful. I mean, it's slow sometimes. Okay, let's run it. I think I forgot one parameter. Practically this box, after the x, y, the width and the height, it will require the line width, which will be 1 in this case. Let's run the thing. Okay, so you can see our box, which is drawn to just surround the spaceship. This is the area that we will use the BLIT command for. So the first BLIT command will use this kind of rectangle just to copy the background part. And then we will draw the spaceship, and the spaceship will be blitted, so to say, into the memory, so that we can reuse it and move it around. Let's do this. For now, let's just comment this line, we don't need it. And let's go on with the first blit. So practically I'm going to blit the position x. It will be the same position, the same coordinates like in the box that we previously used. So it will be the blit position x minus body width side. And don't forget, so this will be read, blit read. Then the position y minus, it will be snout size, snout radius. Then what we will have? We will have the width. So it will be like body width side multiplied by 2. And for the height, we will be like snout radius multiplied by 2 plus engine height. Something like this. What do you think? Now, before using the other blit command, we need to do the first draw of the spaceship. Let's copy this code. Let's place it right here. And then we will need to practically copy the same blit command, but we will actually read into the number 2 register. Okay, let's see if we have this true. Let's run it. I hope no errors. It's side. uh, I hate the fact that it's so complicated. Side. Um, I would love this editor to have a function with the control key. So control arrow to jump through the white spaces. Let's see if we have any error first. Okay, and we can move this thing around. That's perfect. So the BLIT commands seem to be just fine. Cool. Now, BLIT read, BLIT read. Now we have to do I think we can comment. No, I think we will just remove this. And also this. So in this case, I'm going just to make sure that everything's all right. In the first run, we will just clear the screen and then we will do the draw. If last position, then we practically don't call the draw function anymore. We will use the BLIT right command. BLIT right. First, we need to clear the last position. So we will use BLIT right, the first register, and we will position it at the last position X. And we need to be careful that the box will need to be adjusted. So it will be the last position minus X. No, last position is minus body width side. And for the Y coordinate, it will be last position Y minus radius size. No, snout radius. Okay, then we update the last position and then we'll use the BLIT right to write from the registry number 2, which will be actually the spaceship number 2, and it will be the position X and the position Y. And we should see also it in action. I think this one can be deleted to have it clean, and let's run it. Last position X is not declared. Oh, are you sure? Where is that? Oh my gosh, last position. Position. Ah, last position. So there's a typo in here. Let's correct it. Last position. Interesting. Then I think we should be good. Let's see if we have any errors. Last position. Where is it? Last position. Last positions. So last position. Okay. Oh my gosh. Where the heck do I have this position? Oh my gosh. How these arrows can just slip through. Position. F2. Okay, we can see something is working, but it's not actually clearing properly. Yeah, it's so funny. It's not clearing the screen properly. Anyway, what I want to do first, I want to get rid of this print because we don't need it anyway. We know the key codes, everything is silky smooth. BLIT right, BLIT. So something is off with this part. BLIT right 1, BLIT right 2. Something is off here. Mm, I don't know exactly what is. I think we need to specify that parameter for the right. So I was testing this into the emulator, and the BLIT right has this parameter which is in binary format, and I think you need to specify something like this. And also, to be sure, for this one you need to specify this. So if you are curious, you can check into the documentation. They have it properly test not tested, supplied over there. Now it's amazing. I still do see some flickering, which I'm not exactly sure why. I don't like this. It shouldn't do any flicker. Let's see if we can improve this. Bleed right. So this one should 110. I don't know if it's going to work. I still see some flickering. I'm not exactly sure why. But there's a lot of flicker, which in the emulator didn't happen. So it's pretty complicated that these devices, this emulator and stuff, they are really working totally different. So it's funny that you find all kinds of differences between them, although to be honest, I didn't expect in the beginning. So this is how a programmer's world is looking like. It's full of surprises. I did a bit of research. I'm not sure exactly why the flicker happens. I'm a sort of a perfectionist, and on the emulator it was flickering, but with the BLIT commands I got it solved. And I'm pretty surprised to see this on this mighty device, the Color Maximite, which they say it's very fast and has like this graphics capabilities which are very strong. But anyway, I think we can move on to this to improve the input keyboard. So in order to do that, I'm going to use the key down in the game loop. No, first let's define dim. It will be the key code. So this is what we are going to get from the keyboard as integer. And we also need to define a key loop, because we will use a function as integer. We will use a function which will actually return an array of key codes as ASCII codes. And let's do a for loop for key loop to key down. We will use the key down function of 0. So this function key down 0 will return to us the number of keys in the keyboard that have been pressed by the user. And by looping through this array, we actually get each key code in ASCII that the user has typed, pressed. Anyway, loop key loop to key down, and then inside of this we will have the key code, which will be the key down. We call the key down and the key loop. Now actually here the key loop should start from something, which will start from 1 to key down. And now once we get the key code, we need to actually do something with it. And we need to call the handle key press key code. We pass on the key code. Since we have this function already, we don't really need to use the on key thing anymore, and we will just modify this function to be something like handle key press. Our key code will come as parameter, as integer. We need to remove this. What the hell? It doesn't go backwards. What the hell? Anyway, and I think we are kind of done with it. Let's see if we have any errors. Let's run it. No matching next. Loop. No, it's not loop, is next. Yeah, sometimes the syntax is a bit strange. I'm not really used to the syntax yet. Oh yeah, we can see that the spaceship is moving around. It's flickering a lot, which is super annoying to me. But it's actually, doing something, yeah. The movement is really, really smooth. Boom, 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 boom. I like it. Now it's time to try to improve the flickering, and I think we can improve it by using the sprite command. So this magnificent color maximize, which I have right here, I'm going to show you, is having native support for sprites. And let's leverage this support for sprites to see if we can improve our flickering thing. Back to our source code. So in order to use sprites, I mean, they have a whole bunch of sprite commands, but we are going just to need to use the sprite read command, which will read a sprite from a certain, let's say, position and like coordinates, and we will not need the how to say, the erase command, you see, because the sprite will do it automatically for us, so it will keep in mind the background, and we will not need the sprite. The sprite does automatically for us. So let's do we are lucky because the sprite read is actually very similar to the BLIT, so you just need to um, use the sprite read. We will try to use the number 1. Actually, this device should support like 64 blits and like 264 or 54 sprites. So there are plenty of them. So we just we draw the initial spaceship, we read this sprite, and then we clear the screen. Now when something is moving, we just don't need the BLIT, right? Actually, we can remove the whole thing, and we just use the sprite show command. Sprite show sprite number 1, we say the position, and we remove these parameters, we replace it with 0. 0 is actually the layer which is shown to us in the screen. Sprite show commands support a couple of layers, I think 4 layers, I don't know exactly, but in this case we are not going to use that parameter. So let's see how this thing performs. Let's run it. Cool, super cool, but I still see flickering. I don't know why. A lot of flickering, actually. I don't like this. I'm pretty disappointed why there's so much flickering. I don't know. Yeah, and if you go too much on the edges, then you are going to have an error because it's going to out of the coordinates. But actually, I'm very disappointed. Why there's this flickering? I don't know. But still, I mean, this is the way to go. This should be the way to use sprite elements to move things around and do things and design your own games. I will do some research about sprites and how to avoid this flickering because something is terribly wrong. It shouldn't behave like that. I don't know exactly why it does this. The only thing that I can try to play around with is to limit the number of frames per second. Let's aim for 30 FPS. Let's see if we get any improvement related to flickering. Not that much. Mm, I don't know. It's not that much difference. I was thinking that maybe I have some clear screen around, but nope. Maybe if I remove this one, but I don't think it will work. I think, yeah, pretty disappointing, isn't it? Anyway, but I think we actually achieve our purpose. So I practically improved the design of the spaceship. I managed to show you how to work with sprites to some extent, and I also showed you how to move efficiently your elements around. So I think this is a really good starting point for any games that you develop on this platform. So if you have any comments or suggestions, let me know in the comments down below. If you like my video, just hit that subscribe button. It will mean the world to me. And let's make it so that MM Basic is known to the public. So thank you very much for watching.